Hey everyone, in this video we will learn the Cmake tutorial for beginners. Cmake is an open source cross-platform build system designed to simplify the configuration, compilation and installation of software projects. Unlike traditional build tools that are tied to specific operating systems or compilers, Cmake provides a flexible way to manage the build process across different platforms. It allows developers to define their project structure in a platform-independent manner, making it easier to generate build files for multiple environments such as Makefiles for Linux, Visual Studio solutions for Windows, and Xcode projects for Mac OS. One of the biggest advantages of Cmake is its ability to work with multiple compilers and development environments. Instead of manually writing Makefiles or Visual Studio project files, developers can use Cmake to generate them automatically based on single configuration file. This makes it easier to maintain code bases that need to build on different systems, ensuring consistency across various platforms. Cmake is also highly customizable and support both out-of-source and in-source builds. An out-of-source build keeps the generate builds file separate from the source code, preventing clutter and making it easier to manage different configurations such as debug and release builds. The flexibility allows developers to manage complex projects more efficiently. Cmake works by using a script called cmakelist.txt, which defines how the project should be built. This file contains instructions for specifying the source files, setting compilers options, linking dependencies, and defining installation steps. Developers can define different build targets, including executable libraries and tasks, making Cmake a powerful tool for handling both small and large projects. One of the key features of Cmake is its support for Cmake preset, which allows developers to define reusable configurations for different environments. With preset, teams can ensure that everyone builds the project using the same settings, reducing inconsistencies between development and production environments. Cmake also integrates well with external dependencies. The find_package command enables automatic detections of external libraries, while fact content can download and build dependencies as part of the project. This is particularly useful for managing third-party libraries without requiring users to manually install them. Another powerful of Cmake is its build system generators. Cmake can generate project files from different build systems, such as Make, Ninja, Visual Studio, Xcode, and more. This means the same cmakelist.txt files can be used to build a project on different platforms without modifications, greatly simplifying cross-platform development. Cmake also provides target-based builds, which allows developers to specify build settings for individual targets instead of applying them globally. This makes it easier to manage large projects with multiple components, ensuring that each part of the project is compiled with the correct settings. Cmake supports unit testing integrations, allowing developers to define and run tests as part of the build process. The add_task command helps integrate testing framework like Google Tests or Catch2, making it easier to automate software testing. For developers working in teams, Cmake supports case variables, which store configurations options that persist across multiple builds. This makes it easier to manage project settings, especially when switching between different build environments. Cmake is also designed to work well with continuous integrations or CI and development pipelines. It can be integrated with CI or CD tools like GitHub Actions, Check-ins, and GitHub CI to automate the build, testing, and deployment process. This ensures that software is built consistently across different environments and reduces the risk of errors caused by manual configurations. Cmake also offers advanced debugging and profiling options. Developers can specify build types such as debug, release, and rel with dep info to optimize performance or enable debugging symbols. Additionally, Cmake provides built-in support for sanitizers such as address sanitizers and defined behavior sanitizers to help catch memory errors and undefined behavior in code. Another important feature of Cmake is its support for installation and packaging. Developers can define how their project should be installed using install commands and specifying which files should be copied to the system. Additionally, Cmake works with package tools like Cmake to generate installer or binary distribution for different platforms. Cmake's scripting capabilities also allows for custom build logic. Developers can define custom commands and targeting using add_custom_command and add_custom_target, enabling them to execute additional tasks as part of the build process. Cmake supports cross-compilations, which allows developers to build software for different architectures, such as compiling ARM binaries on an x86 machine. This is useful for developing embedded system or cross-platform applications. For managing different compiler toolchains, Cmake provides toolchain files that specify the compiler linker and other settings required for cross-compilations. This makes it easier to build software for embedded devices, Android and other platforms that require specialized toolchains. Another key feature of Cmake is its support for modern C++ features. It helps developers manage compiler flags, standard library dependencies, and features detections, ensuring that their code is portable across different compilers. Cmake provides a modular and scalable approach to build software. Large projects can be broken down into smaller, reusable modules, making it easy to manage dependencies and maintain code. By using the @_subdirectory command, developers can organize their project into multiple directories, each with its own Cmake list.txt file, ensuring better separation of concerns and maintainability. Cmake also includes preprocessor check that allows developers to conditionally enable or disable features based on this system environment. With if statements and options commands, developers can configure builds based on operating system available libraries or use defined settings. This is useful for creating portable code that adapts to different platforms without requiring manual interventions. Another important feature is Cmake support for environment variables. It can read and set environment variables that influence the build process, such as specifying paths for compilers and libraries and include directories. This ensures that builds remain consistent across different machines and development environments. Cmake has built-in dependency management using external project_add, which allows developers to fetch, configure, and build external dependencies as part of the project. This is especially useful when working with libraries that are not readily available in package managers. For performance optimizations, Cmake provides link time optimization or LTO and compiler-specific optimization flags. Developers can use set Cmake_cxx_flags_release-03-FLTO to enable aggressive optimization, ensuring that the final binary is efficient as possible. Cmake also supports building static and started and shared libraries, allowing developers to choose the best option for their project. A static library is compiled into the final binary, while a shared library remains separate, reducing the executable size and enabling updates without recompiling the entire applications. Another useful feature is generator expressions, which allows developers to specify different compile options, including directories and link libraries depending on the build configurations. For example, $config debug can be used to apply specific settings only in debug mode in improving flexibility in managing build configurations. Cmake provides support for testing framework like Google Test, Catch2, and Push-Test. Developers can use the enable_testing command along with the add_test to define automated test case that can be executed after the build process. This integration requires localization. Cmake can be configured to work with internationalizations I18N and localizations I10N tools. It can integrate with tools like GNU GetText to manage translations, ensuring the software can support multiple languages. Cmake also enables custom compiler checks, which allows developers to verify whether specific compiler features or library functions are available before enabling them. This helps prevent compatibility issues across different compilers and platforms. Another key feature is parallel builds, which significantly speed up compilation times. By using Cmake builds in parallel, developers can take full advantage of multi-core processors, reducing the time required to compile large projects. Cmake integrates with profiling and debugging tools such as Valgridd, TDP, and LLVM sanitizers. Developers can use Cmake to configure their project with debugging symbols and runtime checks, making it easier to identify memory leaks, undefined behavior, and performance bottleneck. Another advanced capability of Cmake is integration with package managers like Conan and VCPKG. These tools help manage dependencies efficiently by automatically downloading and build third-party libraries, reducing the complexity of manual handling dependencies. Cmake also offers custom command execution, allowing developers to define scripts that run at specific stages of the build process. With add_customer_command and add_custom_target, they can automate tasks such as code generations, formatting, or documentation updates. Cmake provides extensive logging and debugging options, which help developers diagnose build issues. By enabling verbose output with Cmake, trust expands. Developers can inspect variable expansions and script execution in details, making it easier to debug configuration problems. Overall, Cmake is a powerful and flexible tool that simplifies the build process for complex projects. Its ability to handle cross-platform builds, manage dependencies, and integrate with CI or CD pipelines make it an essential tool for modern software development. Whether you're working on a small open source project or a large enterprise applications, Cmake provides the flexibility and automation needed to streamline development and deployment. Thanks for watching. Don't forget to like and subscribe to see more content like this.